Hello everyone. Today we're going to be looking at the finance unit starting with simple interest. A couple of things before we begin. I do tend to get a little long-winded sometimes in this unit because we are going to talk about some true to life skills that you're going to need to know and understand about financial scenarios. And I just like to talk about that stuff. The second thing is I'm not an expert. I'm pretty good with the math involved, but I don't know. I'm not up to date necessarily with all the changes that might have occurred, since the publishing of the textbook that I used to do this stuff. So, if you know any finance people out there yourselves, they probably have a more up to date understanding of some of the things that we're going to discuss today. But generally speaking, all the math that I'm going to be teaching you is still valid. It's just some of the concepts might have changed a little bit. And especially, like, for instance, the interest rates. Some of the interest rates I might be using here in my notes may be a little bit high based on what the interest rates are today. So that kind of thing might be different. So, first thing I usually ask students right at the beginning of the finance unit is, why is Canada allowed to print money for the country, but you can't go home and print your own money? And I'm going to give chat a few seconds to see if anybody can come up with a reason. So there is an answer in chat saying, if I think what the person is saying is that if everybody went home and made their own currency, there'd be an unlimited amount, and the government makes sure that it has a value by not making a ton, which is a very good answer. But what gives Canada's government the right to print off their money then? What gives Canada value to its money? So it's a difficult question, but it's got a simple answer. Canada has natural resources that other countries want, which gives it a value in the world. And that's basically what makes any country able to generate its own currency. It's based on its worldwide value on the buying and selling markets of natural resources. Canada has trees. We have oil in the tar sands, although that one's having a little bit of trouble these days. We have natural gas. We have fish. We have ore. Thinking of Sudbury. So there's a worldwide value to Canada, and that value, can go up and down based on the markets for how wanted those resources are. Whereas you at home do not have the ability to back up any kind of money you're printing with a specific value. Now you might say, well, sir, my parents own a house, there's value in the house. Sure, but it also has to be controlled and legal currency that is acceptable throughout the country. So, I mean, it's a standard. There has to be a standardized version of that currency as well. So that's basically what makes it illegal, is that normally people can't back up the amount of money they could print off if they wanted to, whereas the government can. So the next question I have is usually, what is interest? And it's tied in loosely to what we just discussed. But what is interest? So interest, after you've now thought of it for a few seconds, if you invest money in the bank doesn't just leave the money there for you to come back. They don't store your money in the vault and then say, okay, well, that person's maybe going to come back for their money. We'll just leave it there until they come back. What does the bank do with your money? That's correct. So chat just said the bank invests your money, and that's exactly what happens. So that requires us to kind of understand what is an investment. An investment is usually companies around the world that are trying to get started, or even companies that are established, can sell off pieces of their company to generate funds. So a company, let's say, wants to start off, they have a really great idea, but they don't have enough money to start the actual process of making their company work. So they say, you know what? We're going to break up our company into like 100 pieces. We're going to sell those 100 pieces for $1,000 each. And we're going to get as many people as we can interested in our product. We're going to go out and talk to people. We're going to say, if you invest with us, this is what our product's going to do. And if they generate enough interest, people would potentially be willing to say, okay, I'll give you $1,000 for that little piece of your company, which allows that company to get started. If that company, and the promise is, if that company becomes big and actually sells their product and becomes very successful, that they could give back a certain amount of money, more than the $1,000, to the people that invested in the company. And whatever amount of money more than that $1,000 would be considered interest. And that's basically what the bank does. And again, I'm not a finance person, so I don't know exactly what companies banks invest in. I mean, there's probably thousands of them out there. But let's say a bank makes $100 interest off of the money that you lent them to invest with. They'll give you a very, very tiny piece of that money that they made as a thank you for allowing them to use your money to invest it. So that's what basically interest is. It's the amount of money you receive back from an investment. Usually a very small percentage of the original investment. So I'm just going to type that in here. Okay. It's the amount of money you receive from an investment. If I could spell properly, this would go faster. Usually a small percentage of the original investment. So that's basically a very simple definition of what interest is. I'm sure if we looked up on Wikipedia or something, we could find a more, scientific or finance version of that definition, but I hope that makes sense. Now, there are two different types of interest that we're going to be discussing. There's simple interest, which we're going to be doing today, and there's compound interest that we're going to be looking at tomorrow. Now, I'm going to kind of foreshadow what compound interest is in what I'm about to write down here. Simple interest, in those situations, you only make money on the invested money itself. So on the original amount invested. And the difference with compound interest is not only do you make money on the original amount itself, but you also make money on the interest amount that you make as well. And usually simple interest is used in scenarios where you owe money, because it's hard enough to pay back debt. When you have to pay back debt on top of the interest that you owe as well, it becomes significantly more difficult. So usually when you're owing money, you're going to be looking at a simple interest scenario. And usually when you make money, you're going to be looking at a compound interest scenario because you want to make as much money as possible. So you want to have interest on your interest. So we're going to be looking at simple interest today. And banks use simple interest in different scenarios. One of the scenarios would be, let's say you had a loan and for some reason you were able to pay off that loan sooner rather than later. Well, because the amount of time elapsed to generate interest may not be, which is usually yearly, by the way. So let's say you paid it within a year. They're not going to charge you interest on interest if you haven't actually made it to the end of the year. So they'd actually calculate simple interest to see how much money you would owe earlier. Another place where you'll see simple interest used is if you go to buy a car, which is in fact my first example here. If you go buy a car, the car companies themselves could finance the loan for you. Or you could go to a bank to get the loan as well. But what they do is they'll calculate the total amount of interest that you'll owe, along with taxes and all the other stuff as well, at the very beginning. And it's simple interest. So you're not charged interest on top of the interest that you would have to pay yearly. So let's say you want to buy the car and pay it off over 5 years. You're not going to have to pay interest over every year's interest up until that 5-year period. All right. So I believe there was a time when that was actually allowed to do. So people would make a killing on interest on interest, but now I believe that that's changed, and most companies will actually, car companies like this will actually charge you simple interest instead. And then they would divide up the total amount that you would owe for the car by how many months there are in the period to pay off the car. So that's the exact example that we're going to look at here. It says John and Mary need to borrow $5,000 to buy a used car. The bank offers to lend them the money at an interest rate of 5% per annum. How much money is owed after 1 month, 5 months, and 12 months. So if we talk about just the language being used in this question before we move on, what does per annum mean? In legal documents, you may also see per a. And that is correct, chat. That is a Latin phrase or word to represent per year. And traditionally, a lot of legal documents will still have some Latin terms in them. So you have to kind of be aware that that might happen. The other thing I'd like to talk about is the 5%. A lot of students will make a mistake right off the bat by forgetting that 5% is actually not a number until you change it into a decimal. And the decimal version is divide by 100 to turn it into a decimal, so it's 0.05. And I want to talk about the fact that in this particular case, we're not going for a full year, but your interest is charged after a full year. So if we want to know how much we're making after 1 month, that's a fraction of a year. It's 1/12 of a year. So we're going to be talking about twelfths if we're dealing with months, because the interest is per year. You can't have two different units in a question, right? So that's just a bit of a warm up here before we start looking at the problem itself. That's how we would break those things down. And now we can actually start looking at the formula for simple interest. So the formula for simple interest is I is equal to PRT. P stands for the principal, which is the word that they use in finance to represent how much money is originally invested or borrowed. R, this should be a lowercase r here. Sorry about that, folks. R is the interest rate itself, written as a decimal, which we've already done. And T is the length of time, which sometimes has to be a ratio, as it does here. So after 1 month, 1/12 of the year has gone by. The bank does not charge you for the entire year. Therefore, here's the calculation that you would use to calculate how much interest you would get after 1 month. Your P, your principal, is 5,000. Your R is 0.05. And the amount of time elapsed is 1/12. So if you multiply those three things, now, just to be clear, 0.05 is a percentage of the amount invested. So anytime you're multiplying two numbers together, one of them being a percentage, you're finding a percentage of that particular value, right? So taxes, for instance, is 13% of the total value. So this is just a regular calculation of percentage times a total, and you're multiplying that by 1/12 for the time value. And we get $20.83. So since this is just the interest, we could then calculate what the total amount owing is, and the total amount is A. A is equal to P plus I. Your principal was $5,000. Your interest is $20.83. And therefore, after 1 month, oops, I was right there, you owe $5,020.83. You just add those two together. Now there's some manipulations we can do to this formula. Sometimes textbooks will use either one of these values. Since I is equal to PRT and A is equal to P plus I, both of those equations can be combined. You just replace the I by PRT and you get P plus PRT. P plus PRT, however, can factor out the P, and therefore you can get P times 1 plus RT. Now, I actually prefer this formula rather than this one, okay? But you can see both of them in textbooks. Now, I think I missed one little piece here. I wanted to talk about, I'm going to go back a couple of slides. Right here, it says that simple interest questions are arithmetic sequences. And you all are just finishing an independent study on sequences and series. So we're going to investigate how is this scenario like an arithmetic sequence. In fact, how is any y equals mx plus b scenario an arithmetic sequence? And we're going to do that by looking at a table of values. So I want to look at month per month. How does the amount of money that you owe change as the months go by? So they did ask us to figure out how much we would owe after 5 months and after 12 months. We're definitely going to do the 5 month because that's what this table goes up to. So the way this table is set up is you've got month 0, month 1, month 2, all the way up to 5, and then you have your interest owed. So at the very beginning, you're investing $5,000. You don't owe any extra interest immediately. But after 1 month has elapsed, you're going to owe that $20.83. Now, what is going to be the interest after the second month? So at the end of the second month, how much extra, so all I'm asking you to tell me here is how much new interest you would owe, not the total amount of interest, but how much new interest are you going to accrue, using that word, during that next month? Can anybody answer me that question? That's correct. It's the exact same amount. And again, a little bit of foreshadowing, that's what makes this different than compound interest. Because to calculate the interest in the second month, we're going to go back to the $5,000. Doesn't matter that you owe $5,020.83 anymore. To calculate the interest, we're always going to use the original value of $5,000, which means it's always going to be the same calculation that we did at the beginning. And that means that number is not going to change all the way down. It's going to be $20.83. Now with compound interest, we will be using the $5,020.83 to calculate the next interest amount, which means the interest is going to go up and up and up as we go. And now we can fill in the rest of this table. We're just adding $20.83 each time, which I'm going to do on my calculator here off screen. Now what's nice about regular calculators that aren't scientific, like the one you might have on your phone, if you add 20.83 to 5,000 and then just keep pressing equals, it'll just continuously add another 20.83. I don't know if the scientific calculators do the same thing. So all I'm doing is pressing the equal button over and over again after the original 20.83 addition. And I get that. So after 5 months, you're going to owe $5,104.15 on that car where you bought it for $5,000. If we look at our first differences. Now, we've already basically discussed this, but just to be crystal clear, our first differences are all constant. And when our first differences are constant, what kind of relationship do we have? And I'm hoping everybody remembers this. It is a linear relationship. But it's also an arithmetic sequence. We could use this formula to calculate how much we would have over time as well. Now, I know the question originally said to find out what it was in 12 months, but I changed it here to 18 because we can use either formula to find any month value at this point. So the way this would work is that our T1 would be our $5,000. Our T2 is our 5,020.83, and on and on and on. T3 would be the next one, right? Well, this is our A value, and our common difference, which is our first difference, is 2083. So that means that Tn is equal to 5,000 plus n minus 1 times 2083. Now, I want to be absolutely sure you understand why this is n minus 1. I think we might have discussed this in class, but I can't remember. But this is really important. Why is it n minus 1? Because how many times did I add 2083 to go from T1 to T2? I added it once. If I went from T1 to T3, I would add it twice. So whatever the number is in the term value here, you always add the common difference one less times than that number. So if I wanted to go to T18, it would be 18 minus 1, which is 17 times 2083. And if I wrote that out this way, okay, I would have my final answer. So just doing this quickly on my calculator here, 5,000 plus 17 times 2083 gives $5,354.11. So we can either use the formula from before. I believe I did do BEDMAS. I was using my scientific calculator. Thank you, chat. Is the answer wrong? I'm pretty sure that's the same answer I got in the previous lesson, so I'll just double check. But I switched my calculator over to scientific notation. Yeah, so it's good. That's the correct answer. Now, I would actually much prefer, personally, to use the financial formulas that we're going to be using. I find this formula a lot easier to understand, okay? Oh, that's okay, Chad. I'm glad you checked. It's always a good idea to check. I actually did have to flip my calculator over. I was using it as a regular calculator and then flipped it to scientific because I knew I had to use BEDMAS. So thank you for the reminder. I appreciate it. I'm glad you're watching. Yeah, so we're going to use the A is equal to P plus I. Now, one thing you've got to be careful, folks, is if the time is given in months, which it has been so far, then you have to divide by 12 to convert it into years. If I showed you an example where the time was given in years, though, you would just use that number as your time value, okay? So let's take a look at some examples here. The interest owed on a $7,000 loan at a simple interest of 7.5% after 20 months. So calculate the following is what it's asking. So it's asking to calculate the interest. So that's just I. So I is equal to P, and you might want to write these separately. What is my principal? It's 7,000. What is my interest rate? Well, my interest rate is 7.5%, but that's not a number until I turn it into a decimal. So 0.075 is my interest rate. And my time is 20 months, but that has to be in years. So to convert 20 months into years, I have to divide it by 12. That's all because the interest rate, even though they didn't tell you folks that the interest rate is per annum, you always assume that it's per annum. All right. So 20 divided by 12 gives 1.67 approximately. And now I can just plug that right into the formula. So 7,000 times 0.075 times 1.67 equals $876.75. All right. So that's just the interest. Oftentimes these questions will also calculate they'll ask you to calculate what is the total final amount owing as well. And that's just a process of adding your $7,000 plus your interest. So your final answer here would be 7,876.75. That would be the total amount you would owe after 20 months. But another thing that could be asked of you is, again, this is all under the big title of calculate the following. Calculate the rate required to earn $100 in simple interest on a $5,000 loan after 19 months. So if I'm asking you to calculate the rate, now I want you to take the I formula and isolate R. So R would be equal to I divided by, and since P and T are multiplying on this side, they're going to come over here and divide, and I'm going to put a bracket around there so I make sure to put that all under the same bracket. And we can now substitute everything in, and we're looking for a rate this time, so we should be expecting some sort of ugly decimal. So what was the interest that we earned? We earned $100, and remember I said earlier that the interest is always smaller than the investment itself. It's usually a small piece compared to the investment. So the smaller number is your interest amount, and the bigger number is your principal. Some students mess that up sometimes. T is 19 months, so I'm going to calculate 19 months in year values over here, just so I don't have to do it within the formula itself. And 19 divided by 12 is 1.58 years, approximately. So that goes in for the time value. And I'm going to put big brackets around the entire bottom. So we've got 100 divided by bracket 5,000 times 1.58 bracket equals, oh, I made a mistake, 100 divided by bracket 5,000 times 1.58, close the bracket, equals 0.012, or 0.013 if we round it off. But that is not the way that you would write the final answer, because the interest rate should actually be written as a percentage. So to turn this back into a percentage, which is the reverse of what we've been doing so far every time we divide by 100, now we're going to multiply by 100, and that gives 1.3% interest. And the final one here is asking what to calculate the time it would take to owe a total of $11,000 from a $10,000 loan with a simple interest of 5%. So in this case, we're looking for T, and I'm hoping that from what we did up here, you can see that it's very simple to isolate T. We just divide by PR instead of what we did in the second example. Now, there is a bit of a problem, and you do have to be wary of this. They didn't outrightly give you the interest here. They told you that you're owing a total of 11,000 from what you invested or borrowed, of 10,000. How much interest was made? So your interest here, you'd have to understand what's happening, not just plug numbers in, and understand that the difference between 11,000 and 10,000 is your interest amount, which is $1,000. So one of the key things in tonight's homework is going to be reading these questions and getting used to the language of the questions. Can you pick out the interest? Can you pick out the principal in the language that they're using? Okay, so when we put that into this formula, our principal is 10,000, our interest is 1,000, our rate is 5%, which is 0.05. And I can do a lot of this question without my calculator because I can cross off those 3 zeros with these 3 zeros, since both of them can be factored by 1,000, and those thousands will cancel out. And then I'm left with 1 over 10 times 0.05. Well, 10 times 0.05 I can do in my head. That's just 0.5. And how many times does 0.5 go into 1? So the answer is 2 years. And this answer is in years because the normal unit is years for your time value. And that, ladies and gentlemen, is the end of today's lesson. So I'm just going to stop recording for the sake of the YouTube video I'm going to